Today we'll be doing the integral from 0 to 1 of the natural log of 1 minus x times the natural log of x squared over x dx. And to start off, we will recall that the natural log of 1 minus x is the sum from 1 to infinity of x to the k over k, and with the minus sign. So we'll plug that into the integral. So we have the integral from 0 to 1 of negative the sum from 1 to infinity x to the k over k, and we have the natural log of x squared over x dx. We could pull the sum out of the integral, so we have minus the sum from 1 to infinity of 1 over k times the integral from 0 to 1, and then we have x to the k minus 1, the natural log of x squared dx. And then from here we can make a substitution, so we'll let a equal the natural log of x, which means that e to the a is equal to x, so dx is e to the a dA, and a is going to go from minus infinity to 0. So we have the sum minus the sum from 1 to infinity 1 over k, the integral from minus infinity to 0 of e to the a to the k minus 1. We have a squared and e to the a dA, but this right here is just e to the ak times e to the negative a, so this will cancel, and so we're left with minus the sum from 1 to infinity 1 over k, and the integral from minus infinity to 0, and then we're just going to have e to the ak times a squared dA, and we'll make one last substitution. So we're going to let minus s equal ak, so this means that minus ds over k is equal to dA, and also that minus s over k is equal to a, and that s is equal to minus ak. So our new bounds is going to be from infinity to 0. So now we have minus the sum from 1 to infinity 1 over k, and then we have the integral from infinity to 0 of e to the minus s. We have a minus s over k squared, and dA is minus ds over k. So if we expand some things, we have minus the sum from 1 to infinity 1 over k, the integral from infinity to 0 of e to the minus s times s squared over k squared, and we have a minus ds over k. So we have minus the sum from 1 to infinity, and we could pull the 1 over k terms out of the integral. So we have 1 over k times 1 over k squared times 1 over k, and then we have the integral from infinity to 0 of e to the minus s times s squared, and I have a minus ds. So that simplifies to minus the sum from 1 to infinity of, we would just have 1 over k to the 4th, the integral from infinity to 0 e to the minus s times s squared. We have a minus ds. We could use this minus sign to flip the bounds. So we have minus the sum from 1 to infinity 1 over k to the 4th, and then we'll just have the integral from 0 to infinity e to the minus s times s squared ds. And then from here, well, this integral, the integral from 0 to infinity s squared times e to the minus s ds, that's just gamma of 3, but that's just 3 minus 1 factorial, which is 2 factorial, but that's just clearly 2. So we have minus 2, the sum from 1 to infinity, 1 over k to the 4th, but that's just minus 2 zeta of 4. And we will use the fact that zeta of 4 is defined to be pi to the 4th over 90. So the integral is minus 2 times pi to the 4th over 90, which is minus 2 times pi to the 4th over 2 times 45. The 2's cancel, and so our final value is minus pi to the 4th over 45. And so that's the answer to our integral.